What I have here is a Scheppach lathe. Zoom in on the label there. It's a DMS 900. I bought this on YouTube. However, when I got it home and tried to change the speed of the pulleys, you couldn't move them. So in the end I had to take the entire shaft off, remove the pulley. While I was at it, I thought I'd replace the bearings. You can see the bearing mountings there. Now this one, the motor pulley, was okay. It was stuck on there, but I managed to free it, and you can see it there moving side to side. This is a variable pulley system. What that means is the pulley gets narrower and wider depending on the tension that is applied to the spindle pulley, which would be up there, and that is adjusted by the speed lever on the other side. So when the pulley is further apart, the belt sits lower down, so the pulley has a smaller diameter, and when the pulley comes closer together, it forces the belt higher up on the pulley, and it essentially has a larger diameter. It's a bigger pulley. You can see there it's come apart, and you put it together there, they sort of interlock, which gives it a continuous surface for the pulley to run on. This bit here is the pulley that I took off. You can see it's very wrinkly, distorted all around the edge there. This is the bit that was left on the spindle, which I literally had to break the sides off, which actually wasn't difficult because the metal was really, really brittle. It almost fell apart in my hand. But I did that so I could get around it and fit the gear puller, which I'll show you in a picture. And this is the reason why I changed it to begin with, because you can see this is really cracked. It looked like it was about ready to fall apart, and when I applied a bit of pressure on it, I lost the outer edge there. It just literally came apart in my hand. Hardly needed any pressure to do that. And you can see the cracks running all through it, so it's pretty dangerous. I would have expected that to fall apart. Anyway, it was stuck fast onto the shaft, literally locked on there, which apparently happens if you don't keep these lubricated. They recommend you use the dry PTFE spray, which you can get in a can, which I'll show you later. And here's the drive shaft. That's the end that the wood would be attached to. There'd be a chuck or a spindle of some sort on the end there. This is the bit that runs inside the machine, and that's where the pulley goes, and the bearings go there, there. This is the replacement pulley from Scheppach. This was quite expensive. It was all in all it was very close to £60 with postage and VAT. It's exactly the same. It doesn't look like a particularly strong metal. I don't know what it is. It's some kind of cast metal of some description, a little bit machined on the front here. A little bit smaller also than the one it's replacing, although it is bigger than the pulley that's attached to the motor, so I don't know whether I can demonstrate that, but you can see there it is actually a little bit smaller. I think it's about 1 centimetre across its diameter smaller. Anyway, so this bit here goes inside this bearing where it sits nicely, and that bearing goes inside this bit there, so it's basically going to be like that when it's assembled but pressed tight together. Alright, well that went in pretty easy. You can see here the new one in. It's the new bearing seated all the way in there. I achieved that basically by putting the old bearing over the top of the new one and just tapping it gently with a hammer all around the edge so as not to distort the bearing. Went in pretty easy, and then I just finished it off with this socket extension. I just took a couple of taps, and there's a ring around the inside there that needs to accept a pin to hold the bearing in. Oh, one other thing is I used WD-40, this dry PTFE. I just gave it a spray around the inside of the cast here, of the casting, just to help that bearing go in, and it did slide in quite easily, so that was good. Yeah, I had a change of plan actually. I thought the best way to do this would be to put this on the wood to support the pulley, and then I took a large socket which I placed just on the inner ring there, so that all the pressure's on the inner ring, and just tapping that bearing down onto the shaft. And that seems to work best because it's only applying pressure on the inner ring where it contacts the sleeve, and the rest of it will just follow down. I found in the end that the socket I was using was resting on here, so this was not working very well. So when I used the socket as far as I could and this started to come through the bearing, then I had to tap the remainder of it down with this punch, which has a very flat bottom. Just gently work my way around, tapping that in. So that's good now. It's as far as it can go, and I just got to put the clip on there. Hi, I'm back again. I couldn't get this ring on with the pair of expanders that I had. Didn't open wide enough, so I ended up buying one of these. They arrived today by a UK company called Faithful, and they open a bit wider, so I'm able to, a bit hard to do it with holding the camera, but I'm able to effectively open this up a bit wider. I'm going to clip it on and then get back to you. Well, there it is, it's on there nicely now, and that keeps the pulley in place. What I've got here is a new bearing that's going to fit in there. You can see inside there, I can get a focus on that, there's a circular flexible pin. There's one at this end and there's one at the other end. It's a clip that just clips in and holds the bearing. So I'm going to fit that bearing in there basically by, whoops, hope that doesn't fall out, using the old one over the top to guide it in, tapping around the edge all the way around, and that should force that all the way in up against that pin. And it shouldn't be too difficult. Again, I put a bit of that spray inside there just to lubricate the cast iron sleeve. Okay, so I got that bearing in. That wasn't a problem. I used the other one to tap it in. Then I took the shaft and I gently tapped that through. So this is loose. It will go on the other side. There will be another bearing that will connect onto the shaft. This part of the machine, the shaft here, is machined, and that's going to engage in the bearing with a few more taps. But at the same time, the other side is going to engage in another bearing. So I'm going to fit the bearing first and come back and see if I can gently drive it through both bearings into place. Okay, so I turn the headstock around. You can see the shaft coming through. Here's the new bearing. I'm going to slide that over there. I'm basically going to force that into its seat there using this bearing and a hammer. And when that's done, the bearings are in place. I'm going to tap the shaft through so that this machine surface and the one that's inside there will line up with the bearing, and then the shaft is actually installed in the correct position. Right, I'll see how that works out. Okay, so you can see there I've got that bearing in. That really wasn't difficult. Just tapped on the old bearing just very gently around in a circle. It didn't take a lot of force, and that's seated in quite easily. So what I'm going to do now is tap on the end of that shaft and see if I can gently drive that home into the position it's supposed to be without popping that bearing out. The one on the other side has a ring to stop that happening, but this one doesn't. But I suspect it will stay in place, and if it doesn't, then I can simply gently tap it back. So I'll see if I get that shaft through. Well, as you can see, I got that spindle on, got the bearing seated properly and got the clip back on, and there's a very thin washer behind that clip. Hi, I wish I could report that this pulley went on easily, but it didn't. Basically the part of the the pulley that went through the bearing. I suspect it must have compressed it very slightly. I mean, we're only talking a thousandth of an inch or something, but enough anyway to make it bind. I was able to put the pulley on, and I tap it slightly and then pull it back. Not applying any pressure to the pulley itself, but tap it on, work it backwards and forwards, and it slowly, millimetre at a time, it sort of worked its way onto the shaft, because what we're trying to achieve here is that this moves backwards and forwards freely on the shaft, which it doesn't at this point in time, but it's better than it was. And I found as it goes further along the shaft, it tends to be a bit looser. Not sure why that was, except for possibly that's where, if there was any wear, that's where it would have happened, because that's where the pulley was moving before. So anyway, I'd recommend that you do that. Just keep moving it back and forwards, and spray it liberally with this PTFE spray till it moves smoothly. And once you get it so that it moves smoothly, I think you're ready to sort of connect it all together. The other bit that didn't go through the bearing fits quite easily, and it does move without any resistance. It's only that piece there that has created a problem, and unfortunately this is the bit that slides. So anyway, I'll keep working on that, and hopefully we'll get a nice smooth action. After a little bit more movement backwards and forwards, I was able to free this to the point where it will actually slide backwards and forwards quite easily. It's hard to show you this with one hand, but there you go, it will move quite easily backwards and forwards. The thing to be careful of is that, I'll take this off to show you. Down there, that bit is operated by the lever. You see it's coming forward and back there. And what that does is it engages in that hole at the bottom of that, and there's a screw fitting at the bottom, a sort of hex nut thing that goes in there, and when you adjust the lever, pushing on this here, moving this forward and back, effectively moves that cast iron block and moves the pulley backwards and forwards on the spindle there, on the drive shaft. So the thing to be careful of is to make sure that this doesn't protrude through the hole when you're sliding it backwards and forwards, and you can see there that it would hit onto the pulley, and if you ramming this thing backwards and forwards trying to, or you may perhaps even take a hammer to it or something, you might find that will come through the cast iron block onto the edge of the pulley, and you'll end up breaking it. As I found, lubricating it with the PTFE spray was great, and then wiping off the shaft every now and again, because you do get sort of very small filings, almost like a grey oil. It turns the lubricating spray sort of grey colour. Presumably it's taking off very, very small amounts of the inside of the pulley as you slide it backwards and forwards to create the clearance necessary for the smooth operation. I could see why you need to lubricate these, because it wouldn't take much for that to get seized up again. So this is obviously one of the weaknesses of this type of lathe, is that you have to keep doing some preventative maintenance on these spindles, which effectively just means you have to spray them from time to time, but definitely something you wouldn't want to forget. Okay, I got the pulley on, and I could put the screw in there, and that engages in a hole in that shaft I was showing you earlier. So make sure you put the screw into the hole, otherwise it might slide off, and then you'd be in a mess. Around this side here, that's the adjusting handle. You pull it out and you move it through the various speeds, 1 to 10. Whoops, 1 to 10. So what I'm going to show you is how that affects the pulley. So as I move it, you can probably see it there, just sliding along the shaft. That's just enough to make the pulley wider and narrower to adjust its diameter. Okay, so basically that's the most important part of this project, is to get that back on there and make sure it operates smoothly, because that's what the problem was. So that part's done. Okay, everything's back together. So I ended up putting the belt on before I put the pulley faces on. This one needed the clip, the C-clip here, and it needed to be tightened down just to stop this pulley sliding about. There's 2 hex bolts there, so don't forget those. This one, the clip goes on, then there's one C-clip at the end here, so you have to compress this spring by hand and put that on. That was a little bit tricky. Seems like it's all done, so I'm now going to turn it on and move that lever across the back there. It's a little bit tricky, but I think I can probably manage it from here, and we'll see what happens. Right, well, the first thing I notice is that it's so much quieter than it was before. It used to scream, and I can assume that that's the bearings, you know. Now it's super, almost whisper quiet. Okay, so let's see what happens when I change. Okay, that top bearing is closing up as I change the speed. The pulley is coming up to the top. There's a bit of rattling there, I'm going to have to see what that is. And you can see, at least I don't know whether you can see, but the lathe is turning much slower. So right now you've got the fullest diameter on the top and the smallest diameter on the bottom. Now I'm going to reverse that and speed it up by moving the lever at the back. You can hear that speeding. You can hear the bottom, you can see the bottom pulley is getting smaller or narrower with a wider diameter, and the top one there is widening apart and basically getting smaller. So you've got a faster drive now, that's turning much faster. Alright, if I can just find out what that rattling is, should be in good shape. So, good job.